Ahudu Billahi Minash Shayatina Rajim. Bismillah Rahman Rahim. We say Alhamdulillah, Alhamdulillah Rabbil Alamin. Allah is Lord of the worlds. My name is Fatiha Sharia. My contact information is researchpublishingmedia at gmail.com. Researchpublishingmedia at gmail.com. This is in association with Dr. Tutor. Dr. Tutor is an educational platform where we tutor young people on any subject, but we specialize in mathematics, and the ages are from preschool to undergraduate. We also do a leadership conference, and the leadership conference is actually very good. Again, we have young black men in American society that do not necessarily have correct guidance to give leadership across the planet. If you do read the Bible, and God says that the black people in America, the black man and black woman in America, the nation of Judah, will be the lawgiver for the planet. Again, the Bible says that the black man and black woman in America will be the lawgiver to the planet. So when you look at the chaos of the planet, and you look at the intentional destruction of black people, specifically black people in America, specifically the black man in American society, if you look at the strategic, the wise intent to destroy them black men, us, is because God says that Judah will be the lawgiver on the planet. We talk about math analysis. Math so difficult, it makes life easy. So then we want to focus on seek ye first the kingdom of God and all of his righteousness. So let's go to the Bible to just get us focused. We want to see where in the Bible, if we go to Bible Gateway. No, first let's go to the internet. And let's type in Judah is the lawgiver to the nations. Let's see what Bible verse that is. Bible verse. Okay, that's the one we read before. The scepter shall not depart from Judah, nor a lawgiver from between his feet. But that's not the verse. What if we say, what if we say Zechariah? In Zechariah, in Zechariah, Bible verse. I can't think, what was it? Zechariah, cannot remember that, brothers and sisters. But let's see if we could just, God might bless us just to go to it. If we say Zechariah, was it 17? Zechariah 17. Okay, no, I don't even have. Okay, let me type it in one more time. What was it? Gold trumpets. Gold trumpets. Judah. Bible verse. Let's see what it says. Okay, no. Let's try it one more time, then we're going to move on and come back. The nation of Judah in Zechariah Bible verse. Okay, Zechariah 12:6. On that day, I will make the clans of Judah like a blazing pot in the midst of the wood, like a flaming torch among sheaves, and they shall devour to the right and to the left all the surrounding peoples, while Jerusalem shall again be inhabited into its place. Zechariah 12:7. The Lord also shall save the tents of Judah first. Now that's actually very powerful when you talk about Master Farah Muhammad coming to America in 1930 to give knowledge and wisdom to the black man and black woman in America. The Lord also shall save the tents of Judah first, that the glory of the house of David and the glory of the inhabitants of Jerusalem do not magnify themselves against Judah. Okay, so we can't necessarily say where it says that, what if I just type in Judah will provide guidance to the nations. Bible verse. Now understand now, each one of them verses I read in Zechariah, listen, they were so profound. Now, I just read over that, and we ain't even speak about it. But I want you to really understand, brothers and sisters, what God said about who we are, the black man and black woman in America, who we are, and the obstacles that have been presented against us for us to be nothing. To the nation's Bible verse. Okay. Okay. Well, hold on a second. Zechariah 10:6. Let's see if we. Hold on a second. You know, the law always come through, right? If we just see what that is. Zechariah chapter 10, verse 6. Let's see what the Almighty Allah says. And I will strengthen the house of Judah, and I will save the house of Joseph, and I will bring them again to place them, for I have had mercy upon them. Okay, so that's not specifically what we're looking for. Let's see if we try, what if we say 12:9, 12, or was it 12:29? That might have been 12:29. Okay, no, they don't even have a 1229. Maybe it was 729. Oh, brothers and sisters, have patience with me. Okay. All right. So, to provide guidance for the entirety of the planet. We talk about math analysis. We wanted to speak about math analysis. Also, I spelled metallurgy incorrect, and that kind of messed with me when I seen it. And it was just up there like I knew how to spell it right. But we're going to talk about metallurgy. Metallurgy. And whenever you talk about ballistics, we want to talk about ballistics. 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 We want to talk about firearms. When we talk about firearms, we want to talk about the pistol. When we talk about the pistol, we want to look at the trigger mechanism. If you're watching the video, you should write this down. Ballistics, firearms, pistol, the trigger mechanism. If you want to get real deep with it, look how Moses, as a black man, black woman, plantation slavery, the gun. We just come right out gun. Now, if you in your own country and you doing things how your government is governing, well then yeah, but that's not what time it is. We're coming from a slave plantation, and in so many ways they want to say we runaway slaves. But on a whole separate level, look at how Moses, from math analysis, has educated the European to structure their learning. Yeah, it is a gun, but no, it's ballistics. It's not just a pistol. It's not just what the scriptures say, when we gravitate to our low desires. No, we're looking at the science of what's going on, our learning. So it's not about, as a human being, you want to learn how to defend yourself. But on a whole separate level, you got to put a value on yourself. What you got in your mind. When I see you or you see me, what am I thinking about? Son, you know how to build a trigger to a pistol? Yeah. How much you gonna pay me if I choose to do that? You see what I'm saying? Just because it's fineries. So if you look at how it's structured to get to the trigger mechanism, it's the ballistics of a thing. It's the ballistics. You can have the ballistics of anything. But we're talking about the ballistics of a firearm, right? They call it a firearm. And then we go from a firearm, it's all kinds of firearms, but we're specifically talking about the pistol. And then when we look at the pistol, we want to look at the trigger mechanism, correct? Because you can have some metal look like whatever it looks like. But if you don't know how to do this trigger mechanism, how that works, and how for you to build it, then that bullet will just sit and it'll be nothing. So that's what we want to speak about initially. But before you even get into any of that, it's metallurgy. And the reason why I just go right to the trigger mechanism, because, in learning it can get boring. And metallurgy, when you talk about building wealth, generational wealth, you look 1,000 years from now and your name, inshallah, will be on the planet and you're controlling a certain area or other planet just with information. That's what metallurgy is. When you get involved in metallurgy, it's not just something you can get into. When you start actually looking at dynasties or rulerships of nations, I would probably say, like, if you speak about America, America hasn't really been as a country for a long period of time, but what has kept America as a country on the planet is its technology. Now we know the technology come from black people. So once black people leave, then the country will fall apart. But it has been the technology. So when you look at the history of Kemet and just assuming the longevity of the Commission rulership was because they had control of what they say are the 4 elements. Correct? So that's metallurgy. So when you get into metallurgy, it's not upbeat. It's a slow process. This is where we are, and this is where we're going to be. Because it's production. And you're talking about lifting tons of weight and the heat and trying to take, so that takes a long amount of time. Long amount of time. So to get it in its correct perspective, well, we can just look at it. You understand? That's not metallurgy, but we can just look at it. But we can put that characteristic on metallurgy. You see what I'm saying? Well, you'll know what's going on. So that's why we're going to start off with the trigger mechanism. And from the trigger mechanism, we're going to try to get into metallurgy. And again, I'm a little bit older. So it's a gradual process. But whenever we talk about metallurgy, right, we got to talk about the brother. Got to talk about the brother. Ptah. Now, Ptah probably go back 15,000 years. When you go to Kemet, and that's probably 5,000 years ago, Kemet will show you a black man. Right? And they're going to say, we don't really know what they're saying about him, but from what we can tell, they say he was the controller god of the 4 elements, the creation god. But really, Ptah originated, or he had the knowledge of how to melt metal, metallurgy. Correct? So we got to introduce him, right? Now, if you go to, let me introduce my brother also, Amun. Amun is also a black man in history. Amun probably go back a little bit, just in looking at Ptah and Amun is a little bit deeper, like how you pronounce it. So I would say he a little bit more of antiquity. He might go back, I don't know, he might go back 25,000 years, brothers and sisters. When you talk about Amun, and when they show you Amun, they're going to give you that black man, he going to have a crown of 2 peaks on his head. I can't remember whether he has a belly or not. But you recognize Amun because he has the two peak crown. So we have my brother. We're going to read about Amun first and just see what my brother say about him. Now let's see. Let's go to, let's see if we can get this book. The name of this book, Encyclopedia of African Religion. Very good book. This is a very good book by my brother Molefe Kiti Ashanti and Amar Mazama. Amar Mazama and Molefe Ashanti. And this brother, Molefe Ashanti, brother Ashanti is in Philadelphia at Temple University. And he's also on YouTube. That brother is like the aristocracy of intelligence when it comes to our history with Egypt, or what you call Kemet. What that means is that whenever that brother come present himself to the people, he gonna give you some of intelligence of a certain level. So he's actually very good. And so again, this book is on the internet, and it's a blessing. We thank you, brother. We thank you, brother, for this information. And we talked about Ptah a little bit. We're gonna read about Amun a little bit, just to get an understanding of who these black men are. And so let's just get into it. Let's see if we can find what a brother is. Okay, he might not have them, brothers and sisters, or either I'm spelling it incorrectly. Let's see if he got the brother somewhere. He might spell it Amen, right? Okay, he got Amun spelled in here. That's okay. Hold on one second, brothers and sisters. Let me just go ahead and go through the. Okay. Maybe he has it spelled with an E. Amen Hotel. Okay, he has Amen. So we're going to read Amen, and we're just going to assume, okay, so when we said, okay, now when the brothers, first of all, let's see who wrote this. Okay, brother Shanti wrote this. Okay, so he says Amen. So when you say Amen and Ptah, well, Ptah would be older. If you pronounce, this is why these things is very important, because if you pronounce it Amun, then I would say Amun is older, but he's pronouncing it, he says Amen, sometimes spelled Amun. Okay, so no, it's going to be Amen. You see what I'm saying? Right there, like a lot of times, we get older, not that we old, but, older wisdom, we don't be flexing our intelligence, but he flexed it right there, right? So we're going to say Amen. I would say, so Ptah is older. So I would say our men probably came, 10,000 years? Now this is not right and exact, brother. I'm just, brothers and sisters, I'm just saying, how I see things. So I would say Ptah is older. So he says, Amen, sometimes spelled Amun, is the name of one of the principal supreme deities of ancient Egypt, alongside Ptah, Atum. No, I was looking for Atum. Ooh, oh, he got a couple of jumps. No, let's look at Atum. Yeah, let's look at Atum. Okay, no, he don't even have Atum up here, right? No, he might have it up here. Hold on one second. Okay, he got Atum. Let's see what this. Okay, so it's not Amen. Ooh. We're going to leave Amen up here, though, because we want to know which one of the rulers, or which one of these black men. We know Ptah didn't wear the double crown, the double, how do I say, the double peak crown. So let's look at what he said. Okay, so we got to put Atum. Now, we don't have no knowledge about who Atum is, but we're going to look at him and find out what's going on with this black man. So this black man's name is Atum. So that's Adam, correct? So let's see if we can just freak it, right? And say, well, we're gonna call Atum Adam. Meaning, right, that ain't even no incorrect translation. They kept the name the same. It's Atum. So when we read about Adam in the Bible, really we getting that history from this brother right here named Atum. So let's see what it says about him. Atum was one of the earliest names for the divine in its capacity as creator God in ancient Egypt. Okay, so listen, right? Whenever they give you any one of these black men, Ptah, Amen, Atum, they all say the same thing. One of the original. So these are old antiquity black men that are in association. Whenever we talk about the creator of the heaven and the earth, we're talking about these black men right here. So God, remember, there's only one God. And then from that one God, who is these black men that go back a certain history that we can't go back? Like when we go back in history, as far as we can go back, we know it's a God in the beginning that created everything, right? So then all of a sudden you got these black men, and they showing you what these black men look like. Equally important, the conceptualization of Atum represents the earliest example of humans developing an ontology or metaphysical philosophy to explain the nature of being in existence. The earliest reference to Atum, and then he got it capitalized now. He got Atum capitalized in ancient Egyptian literature is in the pyramid text and is dated back to 2350 BC. That's not that long ago, right? For him to be older than Ptah. So now we got to get them numbers correct. So that's a good reference date. The brothers say 2350, right? So that's a good reference. Should I write that? I'm gonna write that on the board. So he say a good reference point is 2350. I call BC Kemet. 2350K, we got some documentation of Atum. See how we structure it? It's not just a pistol. It's not just a trigger mechanism. It's ballistics. And from ballistics, it's the firearm. And then the firearm is the pistol. What about the pistol? It's the trigger mechanism. And always understand, right? People not dumb. Mechanism and Mecca. And if you go to Mecca right now, you're going to see the Kaaba. Remember, we got the pyramids right here. It don't say the Pyrrhonism, the trigger Pyrrhonism. That's not what it says. It says the trigger mechanism. So when you go to Mecca, they got a place where you make prayer, where you pray to God. So again, what is you thinking? You ain't thinking about nothing. Whenever you see the word mechanism with whatever you talking about, what is that? How it work? How it work? So I just want to make that point. Okay. So 2350K, you got some literature of a brother named Atum. So that's a good reference. So whenever we go to Ptah and Amen, like it's one thing when you read the book and you just keep it moving. Oh, compared to, look now, math analysis. We learn, this is what we're learning to a point where we get a doctorate in it. So if we say we got a doctorate in whatever Mr. Sharia or whatever God is showing us, so then what we do with that? It's called application. You got to apply that. You got to teach these young children about what's going on. Okay, that's a good point. 2350K, the pyramid text. An analysis analysis of the pyramid text demonstrates that the deity Atum served at least three primary functions. Okay, call him a deity. Okay. I wonder I would have to talk to him personally. Why would he call him a deity? Why would he call Atum a deity? Right? Like, are they getting that from the hieroglyphics? Right? So, that's where like, you start comparing what people say compared to, like, okay, so when you talk about Imhotep, I don't even know if you're going to find Imhotep, but you'll find them pharaohs, them rulers. Well, I was going to say, would you find Imhotep in the hieroglyphics? Like, you probably won't find Imhotep in the hieroglyphics because he wasn't a ruler. But if you read the hieroglyphics of the rulers of Kemet and look at the symbols of what they're saying about this human being that we know this ruler was on the planet. If they're the same symbol, now the people not dumb, they already probably know that, but if they're the same symbols, then, right, you wouldn't call him a deity. But that's beautiful, that's genius. Because if they're not the same symbol, it's like saying if you don't know what it is, we're going to call that variable A, right? So if they got this picture of this brother on this wall, but then he ain't got the same symbols as the rulers, then we're going to say he a deity, right? And then look, right, if they got hieroglyphs of like the hieroglyphs of the animals with the animal faces, with the human being, then you probably would use the word deity, right? But then look too now, the book of Revelation says, and I saw 4 beasts. Them things is beautiful. Like, I really love that, right? Because look, when you look at the hieroglyphs and you see the human being, he got a human body, but he got an animal face. So then the book of Revelation says, and I saw 4 beasts, right? And then the Bible also says in the book of Proverbs, though hand join in hand, God will be the winner. God will be victorious. Though hand join in hand, God will be victorious. So when you start looking at the hieroglyphs, we got the one, it's a video out right now, the brothers just put it out, Heavy is the Crown. I can't completely give you the correct title of it, but it's Heavy is the Crown, Out of Darkness. If you YouTube that, if you go to YouTube and search that Heavy is the Crown, they got a nice video, brothers and sisters. They got some real fluent black men and women, but I know it's black men that are speaking about our history in Kemet, and it's real good. And so they show you one hieroglyph where they got the pharaoh or the ruler, he's sitting on the throne, and on the wall in the hieroglyph, they got black men holding hands. And I think it's 24. So then the book of Revelation says the 24 elders. So all that's just real powerful. But always understand, right, to bring this in here, you got these people ruling. This black man sitting on the throne. He controls a certain authority on the planet Earth, not just Kemet. He controls a certain mindset of the planet. And you got the 24 elders on the wall also, the hieroglyphs, they're holding hands, and that's rulership. But look at what God say in the Bible. You got to get this from the Bible. Though hand join in hand, God will be the winner, or God will be victorious. You see what I'm saying? So that lets us know that there's something wrong with what these brothers and us, what we talking about. Okay. The word atom has been variously translated by Egyptologists as the all, the complete one, and the undifferentiated one. The black man, right? The all, the complete one really let you know there. And the undifferentiated one. No, I mean, you can say that. No, the black man. The black man. Brothers and sisters, the planet is the kingdom of the black man. The word is also a variation of the Egyptian verb tim, meaning to not be, communicating the ideas of pre-existence and pre-creation. I mean, I don't know, we would have to see that, right? Not saying that it's not true. Okay, let's see if they give us like a picture of this brother. No, we don't have a picture. You know what's real good? Let's go to the computer and let's see what the computer says about atom. Let's type in, who is atom? Atum is an important deity in ancient Egyptian mythology, often associated with creation and the sun. He is considered one of the premortal gods and is sometimes depicted as a man wearing the double crown of Upper and Lower Egypt. Now, the computer could be confused with getting Amen confused with Atum, right? Because the brothers say Amen is often pronounced Amun, right? And that Amun and Atum, that's not even closely related. Atum is believed to have created himself from the chaotic waters of Nun. Okay. So you hear that? So when we say God created himself out of triple darkness, right? Okay. So let's do this, right? Who are the primordial gods? Who are the primordial gods? I'm not even going to put like a location on it. Okay, they go to Egyptian mythology, so that lets you know right there, right? Okay, so he said the primordial gods. In ancient Egyptian mythology, the premortal gods are the first deities that emerged at the beginning of creation. They represent fundamental aspects of existence in the universe. That makes a lot of sense, right? If we come from the universe, right, then we represent separate qualities, right? That's just right to take the spookism away from it. The most notable premortal gods include Nun, Atum, Shur, Tefnut, and Jeb, and Nut, Osiris, Isis, Seth, Horus. Okay, that's a lot of people, right? And none of these people, no, they got Horus as a falcon, right? I was about to say none of these people look like an animal, but let me ask, out of these premortal gods, which one has animal depiction. Okay, so when they represent them premortal gods, which one they show as an animal? Sure, shown as a man with a lion's head. Tefnut, a woman with the head of a lioness. Jeb, primarily depicted as a man. Okay, so Jeb. Okay. Okay, so that big woman, that's okay. I know that. I know that hieroglyph. Okay, so Set is human. Nut is a woman that's human. Jeb is human. They don't even show you Atum. Let's say, how was Atum? But they say Atum is depicted with the two-piece crown, right? Okay. So when you start talking about like animal depiction, I have yet to really understand what that means. So we're still on that. So let's ask one more question. Why are they called why I'm just going to ask, why are they called God? The term God is used to describe because they embody supernatural powers. So you got natural powers, then you got supernatural powers, right? That's just metallurgy. Control natural forces that play crucial. Okay, so they call them like doctors, right? Well, that's a low level, but that's really what it is. They calling these doctors gods. But why would you have these brothers depicted as animals, right? Now, just looking at it, you got the jungles of East Asia, right? So as a child, or having child, you know, we children, we come from a black woman. So when you go into the jungle, regardless of how old you is, especially if you're talking about heaven, you can be like, ooh, right? So I don't know, right? Okay, let's ask you this one more question. Why do they depict these deities as animals? Why do they depict these deities as animals? Depicting ancient Egyptian deities as animals or with animal features serves several important purposes: symbolism, attributes and power, connection to nature, cultural identity, visual distinction. Now, the first three are, but visual distinction, right? How would you distinguish? Well, I don't know, you just draw like, unless they look alike, but they don't really look alike, right? Well, I don't know, you might could say they look alike, right? Or like, you could say what characteristic they exhibit, but we're not animals, right? I wouldn't use no animal to depict a characteristic about a black man. But then I don't know, right? Unless he created that animal, right? Like if you're dealing with gold, and you in some way you like a deity, but your manifestations, your application, right? You got gold buildings. I think they had the one brother, like his horses had gold shoes. So I'm going to depict you with some gold. I'm not going to depict you. So you got to look at that, right? As far as like if you're talking about a craft. Okay. So that's still confusion there. But that's actually very good. That was like a brief walk through what's going on. But Again, I say all that to say, well, when we get into ballistics and we start talking about the trigger mechanism, that's dealing with metallurgy, and they got a brother going into our history of the planet named Tutor. And you see Tutor with this symbol with he got a crown like a metal plate. He got a little belly. You see him with like a metal staff. Sometimes he's shown as green, sometimes he's shown as blue. But they say he is the creator God, right? He has mastery of the 4 elements. He had mastery of that fire. Okay. And again, we got the brother Atom, which could be Adam, right? He's depicted in the literature at 2350. So that's a good point where we can pivot around. So whenever you got somebody you focused on in the history of black history, well, we go to 2350K. That's when Atum was documented in the pyramid text. So if you see some information on Ptah, well, what year was it documented? So if they got literature on Ptah going back 5,000 years, then we're going to have to move Atum to the side. Right? We're trying to remember now, when you're talking about a closed set, and you got the variable A and the variable B and the closed set, and we say that A is less than B, right? So that means that if you go to the number line, 0, we're going to say this closed set is greater than 0. So you got A, you got B. Remember, when you see the 2 squares, parentheses, that means that A is included in the set. That means B is included. So we denote that on the number line with a closed filled-in circle and the space in between. So if A is included in the set, right, that means A is the lowest value. You got some value, you don't know what it is, so you call it A. But because A is to the left in the closed set, it's the lowest value, right? So if it's a number set, say we put the set AB in the number set N. Well, we know A equal to 1. Well, how we know that? We know that because the number set starts with 1. It's 1, 2, 3 to infinity. We don't know what B is, but then we can't write that like that. Well, we could. I don't know. That's a good point, right? Because normally when you write infinity, you can't put a closed bracket around infinity. But we know that the lowest set, the lowest number in this natural number set, AB, is 1. I say that because when we find out what black man, or it might be a black woman, but in our slow progression with what's going on, metallurgy, you got to go into the ground and pull it out the ground, brothers and sisters. You got to learn how to control the fire to melt it, shape it, make it into whatever. This is metal. This is metal. This is metal. It be the little things. How we lost. Very much so. Okay. So once we find that point, going back in our history, where the literature says, then we can start looking at that individual and then from there gaining some understanding. Okay. I think I'm going to leave Ptah up here. And I'm still going to wrestle with that. Because we're talking about idolatry. But I think, it's little children, what I'm saying, spicing up the marker board, right? Where it just won't be like dull. Okay. Now we got something real good today, right? It's all good. Well, let me see. Yeah, I wanted to talk about some. Let's see if I can do this too, right? Maybe I might take it down Okay. Okay, let me see something. Let's look at this, right? Some fundamentals, right? Let's look at this right here. So we all know what infinity is. Plus infinity, negative infinity. You have a number line, 0. Negative numbers is to the left of 0. Positive numbers is to the right of 0. Negative infinity, positive infinity. So then we're thinking about a number. We don't know what that number is. So we're going to call that number A. Right? A can go to negative infinity. A can go to positive infinity. No matter what set, natural number, integer, rational number, irrational number, real number, A can go to negative to positive. Okay, so let's understand. This is a fundamental property, trigonometry. As n goes to infinity, I'm going to say A. It doesn't matter what the variable you call it, but to keep it monotonous. A goes to positive infinity. So if you put A in the denominator and you divide 1 by A, if A goes to infinity, then 1 over A goes to 0. You should understand this. Look at it. Like a lot of times we don't even understand that you can just look at numbers. Like how you might look at a woman, right? And how she make you feel and the things you learn. Or you can look at a picture. Or you might look at a word. But you can look at numbers. That's what I've learned. That you can actually look at numbers and God will start giving you information on it. But you should understand this. This 1 goes to A. It never equals A. And always understand that you cannot put 0 in the denominator because there is no number divided by 0. There is no number that's 1 divided by 0. Or that's a number divided by 0. So as A goes to infinity, 1 over A goes to 0. Trigonometry. As A gets bigger and bigger and bigger, this number, 1 over A, gets smaller and smaller and smaller. 1/2, 1/4, 1/6, on to infinity. Each one of these numbers is getting smaller and smaller and smaller. So that means it goes to 0 as A goes to infinity. Okay, that's the first fundamental, I'm going to say building block. That's a good building block for your mathematical library. Right? When you're talking about freaking that math, what you know and what you don't know, or common people, I'm going to use that language. You got common people, right, that know how to do counting numbers. Now, with this fundamental building block, you're a step above where you're actually becoming fluent in mathematics to shape how you think. Because you want to learn how to read the scripture. How you going to read this scripture, this text? Listen, brothers and sisters, we going to the grave. And that's another good fundamental point. Why would God create himself to create death for himself where he going to be dead and that's the end of it? I said that fast. Let me say it again. Let's understand. Why would God create himself? God created himself out of triple darkness. Why would God create himself to create death for himself, where that would be the end of his living. That don't even make no sense, because you're not thinking. That's not nothing you would, because 400 years of slavery, the slave master, I don't want you to know that. Then you'll see you in black skin. Why would God create himself to create death for himself, where that would be the end of his existence? No. He created death, or whatever he created going into the grave as a continuation of wherever he went to, from a God's perspective. Okay, so, no, that's important, but that's for you to understand, to correct what you say you believe and what you say you don't believe. Seek ye first the kingdom of God and all of his righteousness. So look at the trigonometry, right? As A goes to infinity, 1 over A. You deal with fractions all the time. 1 over 2, 1 over 4, this is 0.5, this is 0.25. Right, that's a fraction. 5 over 6, 7 over 8. Fractions. You know what a fraction is. Well, look, 1 over A. As A goes to infinity, 1 over A goes to 0. So look at the devil, right? Ain't this the devil before you knew, right? Before you had knowledge. He walk up on you, right? He say, look, this the devil. Right? They give it to you as the devil walking up on Eve. She ain't know the answer. Right? And had them stressed out in the garden. God said, look, I told you, as A goes to infinity, 1 over A goes to 0. I know they told you that. You didn't forget that. 400 years of slavery. Now it's 2024. You learning it again. Okay, but look what the devil do, right? The devil say, look, if A, this is the trigonometry, if A goes to infinity, then what does 1 over A go to? Right? So you say, I don't know what you would say, right? The only thing you could say is 0. Like, why wouldn't you say, let's do that again. Yo, that's one of them moments. Cause look, either I know that or I learned that. Like, which one is it? I'm gonna tell you like this, right? Even though I learned that, I just felt right there that I already knew that. I don't even know if you understand that, right? Like, I already knew that intuitively. I know that. But I've also just learned that. But look what the devil say, right? The devil say, look, if A goes to infinity, then 1 over A goes to what? If A, a variable, we don't even know, we ain't gonna mess with it, we just gonna say A. If A goes to infinity, then 1 over A goes to what? Well, they go to 0. Right? So now, let's see if we can prove this statement. Now, we done got sidetracked, brothers and sisters, but I got to learn this. Like, I got to learn this, right? So we're gonna see if we're gonna prove it. Now we got to prove it. Now I can show you like A getting bigger and bigger and all. Like all that's good, but that's not what it is. Now I'm not gonna we're gonna touch on this somewhere down the line, inshallah, but I'm just gonna kind of go through it. We got something called epsilon delta language. So this is a limit, what we call a limit. And we reference a limit, we say, as a goes to infinity, f of x, which is a function, goes to 0. And we define f of x equal to 1 over 8. So when I say a function, remember functions look like this, or you can write it like this. That's just one variable. So you got it's not a number line. You talk about space. Space is multi-dimensional. So you can have space and just put the power on it, right? Where you got m, or m squared, or m cubed. And what this is that you got one dimension, which is just a straight line. You got two dimensions, which is planar. You got three dimensions where it's like coming out the board. You draw it like that. And then you got as many dimensions that God wants you to have. That's space. But we didn't collapse it. And they call it Cartesian space now. That's what's really good. That's like when you look at the literature, they give you all these Greek names and they put Caucasian people behind these names. But when they say Cartesian, I think that's Carthaginian. So that's like the only thing they didn't kept that's black people. And Cartesian, when they say Cartesian coordinates, that's like the foundation, how you graph space. Okay. So understand. When it's just f of x, you're just talking about one dimension, x. You might see a function where it say f, x, y. That's two dimensions. Then it might be f, x, y, z. That's three dimensions. Then when you start talking about matter, they got something where it's a upside down triangle. No. We're learning that now with differential equations. Called they got a symbol. Well, they got a symbol where it's the triangle squared. They also have it upside down squared, and you can do it cubed also. You can do it all kind of ways, right? But I say that to say that we just talking about dimensions. When you're talking about the variable. So when you first start off learning, it's just a function. You know what a function is. What's the function of a watch? What's the function of this marker? The function of that book? Well, we got a function. And this function describes system activity. System activity. And once you know what that function is to that system activity, the universe system, then you can do whatever you want to do. But we're looking at HIV, the HIV system. You're looking at herpes. Again, I wanted to get into Alzheimer's. Hold on, brothers and sisters. Let me learn how to spell that right now so I won't be ignorant. I really want to get into Alzheimer's. It's just a tissue. Initially, how I see it, it's not necessarily a cancer. I'm not even going to say it comes from a virus. Right? When you talk about Alzheimer's and Parkinson's, that's dealing more with like equilibrium, balance, and your brain. Now that is a virus and cancer, but it's not at the same type level. Right? So hold on one second. Let me just see how to spell Alzheimer's. Alzheimer's. And see how you see the Arabic in this? Alzheimer's, the all part. Alzheimer's, Zi is Z. Z is number. Alzheimer's, Alzheimer's. Okay, so I say that, brother, because I really want to get into this. And if you at a certain educational level, Mr. Sharia, the Research Library Corporation, I'm not saying we're going to get on the stock market, but we're trying to get into this, right? We're trying to get some of this research finance, right? That's another good point, too. I do research, and when I get more structured and organized, we're just going to be, listen, we do research. What you trying to get, if you got some type of corporation business, whatever you looking at, cancer, the black woman infertility, Alzheimer's, HIV, herpes, right? And you got doctors that are stressed out. They can't move no further. They need like some fresh eyes and ears to do whatever, to point you in that right direction. Research Library Corporation, researchpublishingmedia at gmail.com. That's just to get our finances correct, where we can just buy our own telescope, microscope. We need an NMR machine. We need a chromatography machine. So these are things that, as we learn to further organize. But it's Alzheimer's. Okay. But it's just a function. How do these things work? If you have an incorrect function to describe these systems, you'll never know what it is. So that's why function is real good. So you have a function, brothers and sisters. Let's go back to trigonometry. And we're talking about the limit. You keep putting these numbers into this system. And these numbers is changing, all the way up until it comes to one number. And it doesn't change no more. As A keeps changing. We're going to infinity. A going to infinity. Okay, look now. This function, what's the function? F of x equals 0. You can write this all kinds of ways. You can say f of x equals f of a. Now this is like a little brain masturbation, but we can say f of x equals f of a. I mean, you could write it like that, right? Or you could say f of a is f of a equals 0. But as a goes to infinity, f of x, which is equal to 1 over a, equals 0. So now we got to prove this. So how do we prove that? We prove this with what they call the epsilon delta language. Now, the epsilon delta language says okay, now really look at this now. This is exactly what they're going to tell you when you read the literature. This is exactly what they're going to tell you. And this is what you got to understand. Given epsilon greater than 0, there is a delta greater than 0 such that for A and R, there is a X in R such that 0 less than the absolute value of X minus A is less than delta implies, look at the symbol, f of X minus f of A is less than epsilon. Let's really understand this, brothers and sisters. This is a real live math problem that you have to be master of. You have to be a master of this. You're a doctor of this. But look at what they say. What? Given epsilon greater than 0, there is a delta greater than 0 such that for A in aura, there is a X in aura such that 0 is less than X minus A is less than delta, implies F of X minus F of A is less than epsilon. And I have both of those statements and an absolute value symbol. So given this statement, we want to prove that the limit of X, prove that the limit of X to infinity, we got breakdown. We got a breakdown, brothers and sisters. 1 over X is equal to 0. Okay. Let me change this. Well, no, I can leave it like that, right? Well, hold on a second. Let me change this up to X. Oh, brothers and sisters, we were doing good till we just had a breakdown. Oh, we just had a breakdown. Okay. So we got to prove this limit. As X goes to infinity, 1 over X goes to 0. Okay. So, 1 over X, right? F of X is equal to 1 over X. So this is F of X right here, right? So we put 1 over X right here. And that's just 1 over the variable X. So it's 1 over A. But 1 over A is equal to 0. That's this right here. The reason why I'm confused, right? Because we got infinity. But right here we got 1 over A. So I got to clear that up. We're going to get to that. Just be patient. But this is equal to 0. 1 over A is equal to 0. So that gives us the absolute value of F of X is less than epsilon, which is 1 over X. Right? And we still got this right here, right? 0 less than X minus A less than delta. Okay. So how we prove this right here is, right, is we say that epsilon, we say that X is greater than 1 over epsilon. So if X, now I didn't prove this, but this is just what we're going to say. Well, I can prove it right quick. Look. We say that X is greater than 1 over epsilon. So how do we prove that? Well, we multiply the epsilon to the left side. So this will give us X epsilon is greater than 1. And then we divide the X to both sides. You see that? Trigonometry. So now we got epsilon is greater than 1 over X. That's what we wanted. Epsilon is greater than, let's do it again. This is called, what we're doing, brothers and sisters, is we're trying to prove the limit of a function. what is the limit of a function? It has a limit. It don't have no limit. But this function has a limit where it goes to a certain number. So we have to prove whether functions have a limit or whether they don't have a limit. You'll come to find out that, say you build some type of heating instrumentation. If that heat instrumentation does not converge to a certain where it shuts off, then if it keeps going to infinity, it'll explode or it'll deteriorate, right? It'll melt, the wires will melt, it'll get so hot where it'll break down. So if you have a function, remember function, that goes to infinity, and speaking about some type of heating system, if you have heat in this instrumentation and you're using a function to describe this machine, if you don't know whether that function goes to a certain number compared to it going to infinity, if you ain't proved it, but this system goes to infinity, this machine is going to break down as soon as you buy it. Compared to, well, it's only going to go to this number right here, whatever that number is, we call that number A. So if in the limit, if x, as x goes to infinity, the function goes to A, that means that as long as you have a machine, it's not going to never go past A. Which means you can build the machine a certain way where it can contain A and it'll never break down. Or it'll break down over a certain amount of years. That's why limits are very important, because if you have a function to define a system, you want to know whether that function is telling you that system goes on forever or that system shuts down at a certain value. And then when you gain control of your intelligence, you can make it do whatever you want to do compared to what God can tell. Like God tell you this is it. This is what it is. And so once you have that knowledge, you just know what's going on. So that's why we find limits. And one way to find a limit is called the epsilon delta language. Epsilon delta language. And the theorem is a theorem, a theory. The theorem says given epsilon greater than 0 is just a variable. There is another variable, delta, greater than 0, such that for a variable in R, the real number set, there is another variable, x, in the real number set, such that 0 is less than x minus a in the absolute value bracket, less than delta, implies that f of x minus f of a in the absolute value brackets less than epsilon. I might have said epsilon here, I meant to say delta. Now, I'm still, like, you learn this. First you got to learn it. It got math to it, calculations. But then you want to look at the theory. I'm still looking at the theory, and I'm, again, this is my research, right? So I ain't trying to just come all out, and I ain't getting no finance for it, right? So I take my time to where I can get, we catch a couple research contracts where I got some money in my pocket, then I can really sit back because I can gain control of what I'm saying and I can see what's going on. So I'm still looking at, because it's good. Okay. But you really first got to learn how to calculate it. And once you calculate it, you got to start looking at what the variables are doing to each other. You got a whole bunch of variables now. So how to approach this is what they give you So we say that the limit as x goes to infinity, 1 over x goes to 0, right? And we say that f of x is equal to 1 over x. So look now, we give ourselves this. Where is this in that statement? Well, it's right here. So you put 1 over x right here. Well, what's 1 over a? Well, I didn't tell you, right, but you can also write it, the limit as x goes to 1 over x equals 1 over a, which is equal to 0. You can write it like that also, right? So it's just so that's just another variable. So we got half of that statement, right? Remember now, we taking them steps. Okay. So we got 1 over, in the absolute value symbol, we got 1 over x minus 1 over a is less than epsilon. But look, we're trying to find the limit as x goes to infinity. So we say that's equal to 0. Well, we say it's equal to 1 over a, which is equal to 0. We're making that assumption. So if 1 over a is equal to 0, it's just 1 over x minus 0, less than epsilon. And that's 1 over x, absolute value symbol, epsilon. So now how we prove this, right? 1 over x is less than epsilon. Well, we got to prove it again. We got to prove it again, putting structures around it. Well, how we do that? Initially, we'd be like, damn, first of all, you got to think about it, right? You know, 400 years of slavery, that's real. Tired of thinking. Where are my reparations? 60 trillion. Plus some land. Where is that? But I'm still thinking. I got to think. But okay, let's look at it. Well, we're gonna freak this inequality. We're gonna freak that. We're gonna freak that. Okay. Well, we can multiply the x to the epsilon. So if we multiply the x to the epsilon, this is what we have. We just went from x to right there. So that's 1 less than epsilon times x. Now, we're going to divide by epsilon, divide the epsilon into the 1. So now we have x is greater than 1 over epsilon. That's not what we want. We want 1 over x less than epsilon. Right? But I do that to show you that you can maneuver around the inequality. So if x is greater than 1 over epsilon, if you just multiply the epsilon to the other side, that'll give you, again, x epsilon greater than 1, then divide by x, that'll give you epsilon greater than 1 over x. So that's a true statement. And that's what we want. Because remember when we started, we said 1 over x minus 0 is less than epsilon. This is what we wanted. Right? So how, is this true? Well, we just proved it to be true. Manipulation around the inequality. Epsilon is greater than 1 over x. X is greater than 1 over epsilon. So that's a true statement. So this is true. We got this, right? We almost there. But we got to prove this. I don't even know what this is. Look at what it say now. Implies. Remember that symbol now. 0 less than the absolute value of x minus a is less than delta. Okay. 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 So what I want to do right now, brothers and sisters, we have a lockdown. I mean, you know, I'm not going to sit here and I'm not going to do it, brothers and sisters. I'm not going to do it. So you can just hold on 1 second. Let me see. We're looking at the mechanism. That was an algorithm. I just put an algorithm on the board to solve this. Let me put the problem on the board again. No, I don't even know if I'm writing it correctly. But I put an algorithm on the board, a computer algorithm, a computation calculation. I wrote it, I constructed it's an algorithm. Get the language correct, it'll help you. It's an algorithm to solve problems. I just wrote that algorithm incorrectly. Some of it was correct, some of it was not correct. So let's just see if we can solve it. Let me say limit x goes to infinity . One over x equals 0. Let's see what they say. Yeah, that's a slight on my part. I knew that, right? But I didn't want to front like I knew it, like I know it, right? But I knew that, right? Okay, yeah. Okay. Again, brothers and sisters, that's my error. I've been wanting you deal with limits. Well, we say f of x is equal to some type of infinity. And infinity, this is my thing, right? Like, this is what I want to really start looking at to see what's going on. And this been on my list. I got so much on my list. This been on my list since the professor put it on the board. It's been on my list. Now, I have seen this, right? You still use the epsilon delta language. But instead of saying delta, you just say how, like you say there's a number, there's a letter. You say there's a letter in, say R, no, we ain't gonna say R, but say T, when you have an M and R, where A is greater than R, no, A is greater than M. A is greater than M implies that f of x no. Okay, let me see if that's correct. Okay, so we go back to Okay, so we go back to, that's the conversion of a sequence, but they're using it with a function. Okay, okay, okay. Yeah, that's good, that's good. Okay. This right here is I got to fix that, brothers and sisters. I got to fix that. That's some burnt out wires in my algorithm. I got to fix what they call it. They were some grammar. That's some incorrect. That's some burnt out wires in my algorithm. Because when you talk about, you got something called convergence. When you say X converges to A, it doesn't equal A, but as it goes to A, you have a function f of X that goes to function f of A, right? That's still kind of like, it's still in the same language system, except this time we don't use delta. This is like a lower form. So we'll say given epsilon, there is a variable s in the real number set such that for a greater than s implies f of x. What they use right there. Okay, no, they don't use nothing because we define the value. We got 0 is greater than epsilon. Remember now, we said that as x goes to infinity, 1 over x goes to 0. Let me read it one more time. It's right here, brothers and sisters. Look at this. As x goes to infinity, 1 over x goes to 0. Now we have to prove this a certain type of way. You got rigor showing that as x gets bigger and bigger and bigger, 1 over x gets smaller and smaller and smaller, right? That's not remedial, but it's what I call rigor, like rigorous. Then you just got the delta epsilon language. To prove the limit of x as it goes to positive infinity, 1 over x equals 0, we use the delta epsilon language. We start with the formal definition of a limit at infinity. Okay, this is what I did not completely understand. So we're talking about the limit, the definition of a limit at infinity. So as this variable the limit as x goes to positive infinity, right? The limit of a the limit, what's the language? The limit at infinity. Then we pick back up. For every epsilon greater than 0, epsilon greater than 0, I might need to write it out, right? What you think? For every epsilon greater than 0, there exists a s greater than 0 such that x greater than n implies 1 over x minus 0 is less than epsilon. I was getting this part right here confused. Because right here we use delta. This is like a step up compared to what this is. It's a little bit more easier. Okay. And then once we get here, we know that 1 over x minus 0 is just 1 over x. And then a manipulation of 1 over x less than epsilon. You can switch it back and forth. It shows us that 1 over epsilon is less than x. So because this is true, that makes this true. And because this is true, that makes this limit true. And that's math analysis, and that's proving a limit using the epsilon delta language. And I don't know, brothers and sisters, when I first seen it, I had no idea. I still really, I do a little bit until I start like really looking at it, you know, again, when I get somewhere and I'm grounded, then I can really see what's going on. But that's it right there, right? So that's it. And then you just have to learn how to freak that thing with different types of language. They're going to put different variables. It's going to be different problems. But the mindset is still the same. It's just trigonometry. So let me look at this right quick to make sure so I know right. We talking about the limit at infinity. You got all kinds of limits. I was trying to reference the limit as x go. I got x here, right? I got a here, right? So I was trying to say the limit as x goes to a, f of x goes to 0, but that's not what it is. Like, it's as x goes to plus infinity. So I had got thrown off, right? Because I hadn't really looked at this yet, right? Because I've been focused. Okay, such. But the limit at infinity for every epsilon, or given epsilon greater than 0, look at the language, right? Look at how you use the language to shape what you're trying to convey to get people to understand. You're trying to prove this. For every epsilon greater than 0, or given epsilon greater than 0, right, there exists a s greater than 0. That's not what this says. There is a delta greater than 0. So they're kind of the same, right? Such that for a in aura, there's an x in aura. But that ain't what that says. That says such that for x greater than n, it's not n, it's s. For x greater than, because we use s right here instead of n. Or you could have said n, then you would say n here. Such that for x greater than s, 1 over x, it probably would be 1 over s. I don't know if that's correct, right? Again, we got professors looking, so I would say 1 over s is less than epsilon. But 1 over s is equal to 0 because f of x is equal to what we want to say, 0, which is equal to 1 over s. Right? Okay. Don't get frustrated, brothers and sisters. We're going to come. Listen, we got time. We're just going to keep talking about it until we listen. We got to master it. We're not going nowhere. We're not trying to hurry up and graduate and get some employment. There ain't no employment, right? We're going to praise God. We're going to pray. And we're just going to learn until God put us somewhere where it's the land of milk and honey, and we're going to progress. But again, this is actually very good. And I pray on some level, if you don't have no knowledge and you just hear and you listening to what Mr. Sharia is saying, I pray that you really look at this and you get you a book and just take it one step at a time. Always remember, 1, 2, 3, 4, 5, 6, 7, 8, 9. God showed you that. God showed you that. This is way more complicated than that. Way more complicated, right? But it's the tricknology of the devil. It's an illusion. That's why I always say it's right there. But 400 years of slavery, so God putting our brains slowly back together. Brothers and sisters, they don't even know this. They don't know that. They don't know 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? But God didn't shown that to us. Okay. Let's look at one more thing, right? Let's look at, let's go back to the 1 + 1 is 2. One plus 1 equals 2. We have to prove it. Prove 1 + 1 equals 2. So I took a look at it again, right? I saw what I was doing incorrectly. So we first have to put a boundary. We got to put values on this statement, the variables in this statement. So we said that 0 is less than 1 is less than 2, plus 0 is less than 1 is less than 2 is equal to 1 less than 2 less than 3. And when we're talking about this number system, the number system, we're going to call this number system S. And we're going to say S is the number system, natural numbers, union 0. Now, yeah, I didn't define, or I didn't put a boundary on the natural number system, because we only go to 3, but I just think it sounds better. And I do that too because of slavery. You know, during slavery, that was taken away from us. So instead of using that crutch, right, sometimes it's good, sometimes it's bad. You know, the most honorable Elijah Muhammad say, write it down, or God say, write it down. So I didn't write down that it's 0, that we're going to 3. I'm just going to keep it moving at this time right here until God showed me a certain type of different direction. But this is it right here. Okay. So then look at what we said, right? Phenomenal. Oh, this is phenomenal. We said that, look, we said that 0 less than 1 less than 2 implies 1 less than 2. Oh, that's phenomenal. Yeah. So then look, right? We say 1 less than 2 plus 1 less than 2 is equal to 1 less than 2 less than 3. Now, when we get to this point right here, you can solve this all kinds of ways. I haven't seen, look, if 0 less than 1 less than 2 implies 1 less than 2, then over here we can say 1 less than 2 less than 3 implies 2 less than 3. Right? So that's a thing, like with the stock market. Once you see what you can do on the market, and that's a, God say, prove your path. We done already said it right here, that it implies this. So we can say it again right here. Right? That's just to show something that we can do. But this is what God say, right? This is what God say, right? Okay, hold on one second, How did I do this? I said, Damn, how did I do this, right? I don't know, brothers and sisters. I had a way that I had solved it. How did I solve this? I had solved it. If we subtract 2, right, we say plus 1 less than 0, that's -1 less than 0 plus 1 less than 2. Then if we add, oh, brothers and sisters, I had it. Yes, I did. I had it. Oh, how did I forget it? How did I forget it? I think I brought this down, but I said 1 less than 2. Plus 0 less than 1. Oh, you know what? I did not write it down. All right, brothers and sisters. Let me just look at it again to see if it'll come to me how I did it, right? We're trying to get that 3, right? So if we subtract, that'll be 0 less than 1 plus 1 less than 2 is equal to 1 less than 2 less than 3. You could do it like that, right? So you'll say 0, 1. If you subtract this 1, that'll be 0 less than 1. Then you can add them, that'll be 2 is equal to, no, that's not correct either. Oh, brothers and sisters. Oh, I got to fall back again. Oh, okay, okay. Let me just look at it one more time. 1 less than 2, 1 less than 2. If I bring this down, if I bring that down, now I don't know, brothers and sisters. I got to look at it again. Okay. Okay. 1 plus 1 equals 2. We have to prove that statement. Okay, we're coming up on a certain amount of time. Let's just get right back into it. We're talking about ballistics. Right now we're coming from the science and technology development journal. Science and Technology Development Journal. This is volume 20. Number K2, 2017. This is from my brother Thigh. and my brother Van, Dung and Julian Thai, and Hung and Julian Van, dynamic analysis of the firing mechanism of an underwater pistol. Dynamic analysis of the firing mechanism of an underwater pistol. This is in the Science and Technology Development Journal, Volume 20. I think this is actually very good. So, we're going to get into this journal article, brothers and sisters, and we're going to learn what they're speaking about. Now, if you go to page 62, they call this Figure 2. Figure 2. Figure 2 is actually beautiful. I mean, when you look at the first page, you see like an underwater scuba diver, and they give you Figure 1, two kinds of typical underwater pistols. We ain't gonna really necessarily worry about the attachment of the flashlight and all of that, right? We're just looking at the pistol. So this is what they're giving you in Figure 1. We want to focus on this right here, the trigger mechanism, and all of this right here, how that works. So when you go to Figure 2, Figure 2 says structural diagram of firing mechanism of underwater pistol. But again, we just want to look at, see if we can separate underwater from this trigger mechanism. They give you a very nice diagram. They give you the trigger. It has a slant right here. So that's a gradient. It got a gradient. Then it comes down, another gradient. I don't think the curve is really that important. But I know that gradient, I know this gradient is important. Right? Because you're talking about gravity. So what's that? That's the trigger. They got a slide latch. They have some type of slide latch. Are those screws? Yeah, they might be screwed in. See what I'm saying, bro? Like that's that metallurgy. Where you got something screwed right here that they call a slide latch. That's again at a gradient. And then it one-dimensionalizes. Gradient has a groove that comes down like that. And then they have this trigger fastened again. So you got the two types of pistols. And you got the trigger. That's like a slant. And it's fastened right here, fastened right here. You got something right here that's rounded, comes up. Okay. So they call this right here the slide latch. This is 2, this is 1. 2 is called the slide latch. What's 5? 5 is the return spring. So then when you have the trigger, you got a slide latch. The slide latch is faster. Then you got something right here that's like a spring. And then they got, look now, they got the Cartesian plane, the Y coordinate and the X coordinate. So let me do it again, right? This is volume 20, 2017. So look now, to keep it balanced. X, Y, that's just a space. That's just 2 dimensions. The X dimension, the Y dimension. If you have a function, that function would be xy equals z. That's just a variable. So if you plot x here, y here, it'll give you a point z, and z is that 3rd dimension. That's called Cartesian coordinates, geometry. And understand, when we start talking about HIV and herpes and Alzheimer's, it's differential geometry, how shapes, but we're not talking about like a solid. We're talking about a certain type of mass density, like a tumor, how that changes over time. We might have a independent variable t, and we say t equals time. So how does this tumor, over a certain period of time, how does it change? Well, eventually, brothers, this is Mr. Sharia, God working with Mr. Sharia, eventually the tumor just dissipates into nothingness. But before it dissipates into nothingness, before we make it dissipate into nothingness, like a self-destruction, while it was a tumor, it was absorbing a lot of energy from the human being system. Like if you're a human being and you have a tumor somewhere, God forbid, but wherever that tumor is, it's taking a lot of energy. Well, your body is moving things out the way and taking things in. So you're living with a tumor. It could be any type of disease, but you're living with that. So to get rid of that disease, how does that really affect the body, your human being body? So that's why this doesn't just happen. And that's why it's difficult to make this happen as far as it dissipating, for it to self-destruct. So that's really all we have to learn. Besides learning the environment and what it is and what they're saying it is, what we have to learn is that how come you can't just drink water? Because this is anti-water. But water's stronger than the tumor. But the water just not going to get rid of the tumor, because the tumor then latched on to your energy source. So if it take that source out, you're going to be dead. Necessarily, as far as energy, you don't know what's affecting what. So that's what time is. Over time. And we do all that with space. Space is matter. And you talk about when you actually see photos or like a live film reel of space, it's always moving, even though space ain't got no time. We put time on it. But if you just look at space, it's always moving, right? So you talking about we define that, right? It's incorrect language, but they call it Cartesian coordinates, right? Because that's still chemic. But in the language, that's just 2 dimensions. We say the x dimension, the x-axis, y-axis. But that's a plane. That's flat onto the board. So with it being flat, right, that keep our coordinates, our dimensions correct, so we can understand the diagram. So now you got a trigger. Now understand this part right here is a gradient. I'm gonna focus on that. That's going. God just say, look at that, because that's gonna really affect how fast we want them bullets to come out. Then it has a slide latch. Okay, yeah. Oh, yeah. Okay, okay. Yeah. So then, right, you got the fastener here, right? It's fastened. You got some type of latch. So when you pull this trigger back, if you put it in the X direction, look now, X direction. That's where the gradient is important, because it's gonna slide something. Is it gonna slide it back? It looks like it's gonna slide it back because it has a groove here, right? So that groove gonna push that thing back, right? So what they say 3 is? 3 is the slide. Okay, so hold on. You got the spring. You got a spring here. Okay, so this is 1. The slide latch is 2. This right here is 3. 3 is the slide. 4 is the firing pin. So they got the firing pin right here. So we want to look at how to make the firing pin. Construction. Construction of firing pin. That's metallurgy. So we talk about the brother Tutor. We know Tutor, right? They got some of his writings in Kemet, what they call Kemet. So this is what I say, brothers and sisters. I got a lot going on. So I might not be able to get to the firing pin like right now, but if you ain't doing nothing, listen what I'm trying to tell you. You got to put a value on yourself. You ain't necessarily got you can't even go to these colleges and learn that. But you can go to a metallurgy university or someone that's doing metallurgy. You can learn it like that. Or you can just educate yourself. And then you go to the country where they got the metal. It's not just Africa, but it's in Africa. You tell them people, look, I know how to make a firing pin. You got the land where the metal is. Let's work together. Just put me up, give me some land, and give me a couple dollars, and let's get busy. And that's it. Your 400 years of slavery will be over. Go back home. But I say that to say again, this right here is a firing pin. Then they got something coming out, right? But this right here is 4. Firing pin. So you got the slide latch. This is real intrinsic or particular. So we're going to make the trigger. We got to make the slide latch. That was just little metal pieces. But you got to manipulate that fire. Get it to that. We talking about our junk gonna be steel. It got to be steel initially. I mean, we ain't freaking no plastic. So you got to get that temperature where you got to get that molding, right? But the molding ain't really easy. You catch your brother from Africa, you tell him make a molding out of wood. But it's the slide latch, the trigger, the slide. Remember the slide now. The firing pin. We really want to focus on how you make the firing pin. right? You go to anybody that's making guns, Smith and Wesson, I don't even know. 357 Magnum, 38s, whoever making them weapons. And you tell them, look, I guarantee they hiring. You gotta know how to make a firing pin. However much they pay. Right? Yo, unemployment, government subsistence, that's over with. You back working fully functional. Or you can make it for yourself. But it's a firing pin. Let's see what else they say. A return spring. Okay, this is the return spring. So I guess when it goes forward, that's very important too, right? A lot of guns, well, this is an underwater pistol. Now again, right? So once we just learn this, right, that's kind of like, that's very rudimentary, right? And that might be what it is, though. We need to get, that's a good pivot, right? Because they talking about something they done made compared to like, I mean, I don't even know no gun, but like if you do talk about a Smith & Wesson, right? Do Smith & Wesson got a firing pin where the slide go back and come forward? Okay. Let's see what else they got. Anything else labeled? Because they got some nice symbols. But it's the trigger, the slide latch, the slide, the firing pin. That's why I love these brothers from these black countries that we talking about they not black because they not African, you know. But that's why I love these brothers, because that's me giving it to you. Brother, what I'm trying to tell you, Benson James or Benson Henson, not going to give you that. Not at all. But these are basically 1, 2, 3, 4, 5. Return spring. These are basically the metal parts that you're going to have to manufacture. So whereas we going on the planet, we don't need no metric tons. Initially, we just need about 10 pounds. Where you gonna go and pull up 10 pounds of, it's a metal ore, right? Then you got to learn how to separate the ore from the actual metal. That's not difficult. It's already mapped out and everything. Remember Tutor? How you think? Tutor and them was doing it big too. Right? Anytime you see, the thing, brothers and sisters, is that the devil has made it complicated. But if you look at the pyramids, I took the pyramids down, but if you look at the pyramids, no, it's so much resources right here. It's very simple. You probably can just get the ore and drop that thing in the Nile River, and it'll just separate into your metal. Then you got to control that heat. That's the only thing God showed me that's going to be kind of difficult. Well, we just can't run and get and do it real fast. We got to, because you got to get the temperature, a certain amount of heat. And so I don't have no knowledge of that. And then you got to have something to keep it. That's a container. And that's that thick steel. So you got to make that. And like, you know, that's difficult. I'm assuming because of the size. Okay, so let's take it from page 61. Let's read the abstract again. The abstract, should I put the gun? I'm gonna draw one of these guns up here to show you, to give you an idea of what we're talking about. So you got the trigger here. You got a slide here. The firing pin is right here. I think this whole thing slides back. And you got a spring here. You see what I'm saying? And then you put the steel casing on it, however, okay. The important problem of designing underwater pistols was analyzed and calculated the dynamics of the firing mechanism. So we want to thank these brothers. Listen, they calculated the dynamics of the firing mechanism. We want to thank these brothers, and I'm going to be honest with you. If they had like a GoFundMe page, I would send them. Actually, I probably will. Well, before I say that, this is charity. We got a Gmail. Okay, yeah, they from the. Okay, where are they? They in Okay, they don't really say where they at. Okay. The paper presents a theoretical model for analyzing the dynamics, such and such pistol, with the resistance of water acting on the firing pin in the slide. Okay. Acting on the firing pin. So how does water is just pressure? Yes, pressure. So how does the pressure, so we're talking about external pressure. How does external pressure is mass, meters per second squared. kg means mass, kilograms. Meters is distance, meters, and per time. So the mass, you got a certain amount of mass on a certain amount of distance. You can write this also area. Area, damn, what is it? Area times, okay, I forgot that. I think it's area times force. You have a certain, I think it's area times force equals pressure. I believe that's what it is. So you got an area times, so you get the area from the meters. I really get into them things right there. But you got pressure. Pressure is mass on a certain area. So how much pressure is this ruler? This is very important because look, if you don't create this with enough resistance, then whatever amount of pressure, which is equal to force, Okay, so pressure divided by area is equal to force, and force times area is equal to pressure. Okay. So how much pressure is the ocean putting on the firing pin and the slide? It got the slide back. That's good because if you get it to the point, remember it's metallurgy. So you got to make that metal, you can't make that metal out of no tin, right? Because our standard initially is going to be underwater. Well, that's a great amount of pressure compared to in the atmosphere. Well, that ain't really no pressure. So if you create your firing pin and your slide to be able to stand that underwater pressure, then you ain't got to really worry about it being able to function in the atmosphere, but you don't want it to be too heavy. So that's where you got to learn how to really manipulate that metallurgy. And again, we very far behind. But that's not no reason to get discouraged. We just got to take our time and mind our business. The result of this research can be applied to design the underwater pistol and underwater firearm. Okay, then it says introduction. The underwater pistol is designed to destroy enemy personnel. They just get real with it right quick, right? With up to 20 meters. 20 meters is 1,600 meters in a mile. I think it's 1,600 meters in a mile. The underwater pistol is designed to destroy enemy personnel. He called that enemy of personnel, right? How far is 20 meters in feet? "20 meters is approximately 65 feet. 65 feet. 65 feet is how many yards? 65 feet is a good distance, right? Underwater, woo, 21 yards, 20 yards. So you're talking about shooting a bullet 20 yards underwater? I don't know, right? Yeah, that's a task. Firing underwater is possible from all swimmer positions as well as against surface targets from underwater. Now that's powerful, right? That's almost like the beginning of submarine construction. The pistol is intended for combat swimmers, something that I wouldn't be interested in. Two kinds of typical underwater, okay, they give you two types, one made from Germany and one made from Russia. This one right here is one made from Germany. The Russian one is nice too. That's the one with the sleek, it has a sleek barrel. In Vietnam, the research on underwater pistol is limited, and water commando forces have not been equipped with this equipment, with this weapon. The researchers are mainly focused on projectile motion. That's another good area to study, brothers and sisters, when you talk about equations, differential equations. So design underwater pistol has become a hot topic. Again, this is 2017, not that long ago, right? Okay, so then they say, dynamic model of firing mechanism of the underwater pistol. The firing mechanism. The principle of operation of firing mechanism of the underwater pistol is based on the operation of the typical pistol. So we just naturally assuming we can use this on a regular pistol. But it is improved to reduce the resistance of water. The firing mechanism consists of a trigger, 1, the slide, 3, the slide latch, 2, the firing pin, 4, and the return spring. And I'm gonna make it so bad, brothers and sisters. You go to Alibaba.cloud and you can get all them things made, but you probably got to buy a wholesale price on it. Fire process comprising 2 stages. Okay, they go to figure 2. Okay. Stage 1, slide and firing pin moves backwards. Okay. Okay. The slide and the firing pin, this can move back. Cartesian coordinates, X. What's that? 3 and 4. 3 and 4, they slide back. After pulling the trigger. No, okay. Slide and firing pin moves backwards. After pulling the trigger, trigger 1 motions and impacts on B point on the slide 3. after pulling the trigger, you pull the trigger, trigger 1 motions and impacts on B point on the slide to make slide and firing pin move backwards. Okay, so they're saying that they call this point right here, this little groove, they call that B. So when you pull the trigger, in the X direction, X greater than, it's increasing. This is where math analysis comes in real good, the language. X is increasing. Right here, X is at 0, the trigger is at 0. It's at rest. When you pull the trigger, that means the sliding pin. You pull the trigger this way. You pull the trigger this way. At point B, that makes the slide and the firing pin go this way. So that means you have an increase in X, increasing. X equals 0. Now you have what is change in X. We use this symbol to represent a change in something. Change in X. Now X is greater than Z, greater than 0. To make the sliding pin, to make the slide and firing pin move backwards. So this right here is going backwards. Stage 1 ended when the catch is not contact with B on the slide. Woo! Oh, that's confusing. Stage 1 ended when the catch is not in contact. Oh, okay. Okay. So they have this right here where you pull the trigger all the way back, it'll push the slide all the way back. Then they have it. This is where the intricacy comes in. When I keep saying the gradient, how we got the particulars. They have this structure where when you pull this trigger, this will slide back until it's not in touching this no more. Where it's not holding, it's no resistance no more. It's going to be resistant, resistant, resistant. Then they have the slide latch where it'll sort of like disconnect from the slide. Then I'm assuming that thing going to come forward. Stage 2. Slide and firing pin moves forward. Okay, yeah. So that's good. Oh, that's real good. So yeah, brothers and sisters, we got to learn how to make this right here initially with the firing pin. Because when you have the trigger, and then you got the latch, but they got the latch connected in a way where if you pull this back, yeah, they got it where, oh, they got it like this, right? Hold on, let me write this correctly, right? They got the slide latch. They got that thing kind of like, and then they got the slide. The slide fits. The slide fits like right in there. I don't know if you can really get a good look at that, right? But they got the slide latch. And remember, the slide latch is connected to the trigger. So you pull the trigger this way, and they have like a little groove. You got the slide, and it come down like a little dip. And then the slide latch has a little groove, so when it goes back at a certain distance, this'll come down, and this thing right here will then come forward. So let's see how this bullet works. Slide and firing pin moves forward after the catch. Number two, the slide, this slide right here, is not in contact with point B. When its slide comes down, or when it pushes back, and this goes way back, slide and firing pin under the action of recoil force of spring. Okay, so this, okay. You see that thing is real, that's like real rudimentary, right? So I thought the spring was like coming forward to brace the resistance. No, they talking about you got the spring, you got a little piece right here, that's connected to the slide. You got the firing pin. Then you got this little piece right here. Then you got the little piece right here. So as this goes back in the increasing X direction, this spring, it stretches. You see that? So you're talking about resistance, right? It has to have a certain amount of resistance. The slide and firing pin move forward under the action of the recoil force of the spring. This spring right here, it stretches it. It's going to stretch. Then it's going to come back forward. Once this slide latch disconnects from the slide, firing pin moves forward and strikes the primer on the bullet. Okay, so that's another word we have to learn. Primer. Where can I put that? Primer. P-R-I-M-E-R. So we have to learn how to make bullets. So instead of just going to bullets, Googling bullets, Google how to make a primer. How you doing? If you could give me about 5 or 6 minutes, I appreciate it.
Why?
I was actually doing something. You could just give me 5 or 6 minutes?
Are you a student here?
Yes, sir. Yes, sir. I appreciate it. How y'all doing?
Great, thank you.
Yes, sir. Yes, sir.